So I guess today we're going to be talking about alkanes. So recently we talked about the prefixes, and if you haven't watched our video, it's okay. You probably know these then. Meth, eth, prop, boot, bent, hex, hept, oct, non, and dec. Now these are quite common. You will need to know these for all of the carbons. However, for anes, our suffix is ane. So in this, it's only a prefix and a suffix in this simplified version. So what this means is, let's for example take prop. So we have propane. Then we'll have, we'll do oct. And then we'll have ane. Now when you think about these, you'll probably remember these. One is for the barbecue you might be doing in the summer. Octane for gasoline, right? Octane rating. Now how do we do this with alkanes? So one thing is we have C, 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 because we have 3 carbons here. Now we have C's over here, and we're going to fill up the rest of the valence shell with these extra lines, because we know each C has 4 bonds, or possible bonds. And in all of the ones that have nothing written on it, they will be H's. So now how do we write this down? We could write this as C3, because there were 3, H, then we count each of them, and it's an 8. Now how do we write this down if we don't want to write it in a diagram way? So you could do CH3, CH2, CH3, and you could make sure there's 3 over here, 2 over here, and 3 over here. Now comes the question, is there any easier way of remembering which one's which, right? For example, rather than counting each of the H's. So for alkanes, the formula that you should be knowing is Cn, N for the number of carbons, H, 2N plus 2. Now we'll do an example in which this is really helpful. So we'll have octane. So before this, we'll use this formula and we'll see how we get. So we have C8, H, 2 bracket 8 plus 2. So I'll do a step by step. C8, H16 plus 2. So we end up with C8, H18. Now what we'll do is we'll do the C's. Fill in the blanks. So I won't be putting the H's in because you don't really have to show the H's as long as you know they're there. Reason is because it is universally assumed this stands for an H if there is a blank spot in an organic molecule. So now let's do this. We'll have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So I didn't have to do the counting. And in case I had messed up, I would have known it would have been 18 either way. So how do we write it in the other form? So we have CH3, then we have CH2, then we have CH2, then we have CH2, CH2, 1, 2, 3, 4, 5, 6, and then we have CH3. So this seems really complicated. Now how do we simplify this? We basically group the like equations, I guess. So we have CH3 because we don't have anything right beside it that's the same. Then we'll put a bracket and we'll put CH2 because we know there's a few. Now we'll count how many we have. 1, 2, 3, 4, 5, 6. So this 6 on the bottom just refers to times how much. Then we have CH3. Now why don't we put CH3s in group together? Reason is because then the formula basically gets ruined. Because then you'll assume there's a CH3 here, then you'll go like, wait, are they split up or what's happening over here? With this, you know the exact pattern. And that's it for alkanes.